again, a founder and CTO at AlmaBetter. So I hope you all are having a great day, right? So this week we have started learning about modules and packages, right? So the first library we learned about was NumPy, and then yesterday we introduced Pandas, right? So we learned about how Pandas is such a useful library, and today we're going to see all those manifestations and demonstration of the fact that Pandas is indeed a wonderful library, right? So yesterday we did some exercises together, right? So we were able to read a CSV file stored in a particular location in our Google Drive, right? And then we were also able to write that file from the Python environment to that uh, Google Drive folder, right? So today we are going to uh, yeah so today we are going to talk about more functionalities and operations which are available in Pandas. Okay, so um, today we'll be talking about few more functionalities, so that we can manipulate our data, explore our data, right? So you'll get to know what we mean by manipulation. Okay, so firstly we'll talk about indexing and slicing operations, and then we'll talk about how we can manipulate columns, etc., how we can rename columns, drop columns, or maybe create new columns, etc. And then we'll explore a very few handy methods, such as, let's say, if we want to find the number of unique values a particular column is taking, or the missing values which are present in our data, right? So we'll try to see all those things which we can do with data, right? So whatever you can conceive of, you can tell that on the chat, and we'll try to do that together. Okay, so needless to say, the first two statements will be import pandas as PD and import numpy as NP, right? So this is where you become 10% of the data scientist. Okay, so we'll simply run these particular cells. So firstly, I think you're all familiar with this process of how you can mount a drive in your Colab, right? So it was a pretty straightforward, right? So you can simply click on mount drive option. It will generate a piece of code which you need to run, and then it will generate a link on which you can go, and then generate the key, and you need to copy paste that particular key to mount your drive, right? So we already did this step, so I'll not be repeating this particular thing. Okay, so let's go ahead. I think you guys can also open your notebook. Okay, so make a copy of the notebook, and you can start working with me together, right? So just let me know if you're facing any issue understanding a particular statement or a code, so that it will be really useful exercise for all of you guys, right? So before I go ahead, I just request all of you to just make a copy of this particular notebook, and be ready with the data set. So I think everything is available in your dashboard, so you can access it from there, and then make a copy, and just try to follow along and see if you're able to just at least replicate these particular codes. Okay, so okay, so just let me know once you are done with this, right? So just create a notebook, and also create the data, in fact copy the data, and put it in a proper folder, as I've already emphasized time and again. Okay, so I'll just give you guys 1 minute until I just okay, so this is the data which we have. Okay, so let me see. Okay, so I was able to read. So yesterday, remember, we did not write this particular thing in the path, but in fact we added something like plus, and then we wrote the file name within the codes, right? So but here today we'll only be dealing with a single data file. So in our data folder, we don't have multiple files, we just have single files. So that is the file we'll be working with, so we don't need to bother about mentioning a specific directory path. In fact, what you can simply write this as file path. This makes more sense, right? Because now we are just writing the file path. Okay, so I'll just try to execute this again. All right, okay, so let's explore our data set. So we have now loaded the data set, and let's see what is the shape of our data set. So it has 3000 rows and 23 columns, right? So we do not yet know what the data exactly contains, but we know that, yeah, this is an IMDb movie data set, right? Um, so I hope most of you guys are aware about the IMDb, right? So this company, right? So they, uh, yeah, possess a large, in a very huge information about all the movies which have been released, uh, or even they have not been released, right? So they have all the information about when a particular movie was released, what was the budget, who was the cast, right? So they have sort of become very standard, right? If you want to look for any particular movie and find out all the details regarding it, right? So IMDb dataset we are going to use today. Okay, so let's go ahead and run this particular cell in which we just want to see what are the top 5 rows so that we can basically navigate the data a bit. Okay, so as you can see, first of all, don't worry about this ID thing. We're going to drop this column, and the time will come, but don't worry about this particular ID. But as you can see, if we have different columns like belongs to collection, then you have the budget, then you have the genres, right? So whether this particular movie is in comedy, is a comedy movie or a drama, or maybe a thriller, something like that. And then the home page contains the URL for the home page of that movie. Okay, and then there's the IMDb ID, which is unique for each movie. And then we have the original language, that is, so EN is short for English, right? So original language is the language in which this movie was originally made. Okay, and then you have the original title, right? So this is the original title of the movie. So at times it might happen that some movies name, they might get changed, right? For example, Padmavati got changed to Padmavat, right? So these things can happen. So that's why we have this column original title, and then you have the overview, right? So essentially overview is what's there in the movie, right? So it gives you a basic glimpse. Of course, due to space constraint, the default way Python seemed relevant to show this by trimming the characters which were coming after a certain value, right? So we can of course print the entire set of things, but for now we'll just yeah, hold on for that. Okay, and then we have the popularity or column which determines the popularity on a certain scale. This scale is actually not known, so we'll not mess around with this particular column, but we'll just keep this in mind. And once you do a lot of exploration around this particular column, then you can assess what's the scale they are measuring. Okay, so for now, yeah, we'll not bother about this particular column. And then you have the poster path. Okay, so this is the uh, path to the poster of the movie, right? So I hope, yeah, you are aware about that. And then you have the production companies, right? So there are a lot of different big production houses which finance a movie, which right? So there are like Paramount Pictures, and you have Disney, and then you have a lot of Columbia Pictures, etc., right? And then you have production countries, right? So in which countries these movies were produced, right? So this is information about that, right? So of course, I guess you guys are aware that every row or every observation corresponds to a single movie, and these are all the information that we have for a single movie, right? So popularity, poster path, production countries, and then the release date is there, and then you have the runtime. Runtime is essentially the movie length, and then you have the spoken languages, right? So some movies can have multiple languages which were spoken in them, right? So that's the spoken languages. And then the status, so status can be released or something else. Okay, let's say if a movie was planned and it was also produced, okay, uh, but it was not due to some reasons that movie could not get released, right? So that will be available in this status variable. And then we have the tagline. Okay, so I don't think you need to you already understand this particular thing, right? And then you have the title of the movie, right? So this is the title, and then we had one original title, right? So original title was initially what the movie was named, but of course, let's say later in time, that title got revised, so that's why we have this title, which is not the original title. Of course, for most of the movies, original title and title would be the same, but we'll see that, yeah, for some set of movies, these title and original titles, they're not the same. And then we have the keywords. Okay, so uh, what are the keywords which describe the theme of this movie, right? And then we have the cast. Okay, so who was the cast? And I think you guys might be a little intimidated by seeing these values, right? So it's something like a list of dictionaries. It's not even single word or single number, but it is in fact a complicated data structure, something like a list of dictionaries, right? But don't worry, we know how to play around with these data structures, so it will just be um, a left hand play for all of us, right? And then we have the crew, right? So who was the so who are the crew members for that particular movie? So we have all those details. And then how much, what was the revenue for this particular movie, right? So how much were they able to generate in terms of capital or money? Okay, so this is the overall inspection of the data set. Of course, we were just looking at the different columns which are available to us, but of course uh, we have around how many columns? So we have around 23 columns and 3000 rows, right? So there's a lot to explore. And in fact, as you can see, that even within genres, you have multiple things, right? So it's essentially a list of dictionaries. So there could be multiple genres for a single movie, right? So single movie could be, let's say, comedy, but it can also be horror at the same time, right? So there could be multiple genres and overlapping genres in a way. Okay, so that we have in the data set. And then we can check the last 10 rows by using the tail method, which I talked about earlier in the last class, right? So let's go ahead and just execute this, and we can see the last 10 rows, right? So something like, and you are familiar with this NaN, right, which is short for not a number, and these are used to denote missing value in your data set, right? So okay, so okay, so one person is asking how to load a data set. So it's pretty simple. So you just click on this. Maybe I think I would suggest you to go through yesterday's lecture, and I think, yeah, that you should be able to find it, right? So we spent some 10 minutes on just doing this particular task. So I think you should be able to do that. Okay, so just go through the yesterday's recording and you should be totally fine. Okay, uh, all right. So this is we just printed the last 10 rows of our data set. Now let's move ahead. We want to do a lot more, and we want to explore the different set of possibilities that we have in Pandas, what set of things that we can do. So though everything will be covering today. Okay, so firstly, let's have a basic look at the overall information or summary of our data set. Okay, so we can simply run this df.info. Remember info from the last class, right? So we have 23 columns, and as you can see, belongs to collection has only 604 non-null values. Rest 2400 are null, right? Similarly, budget has zero null values, which is a pretty good thing, right? So always we'd want in real life to have all the data information available with us, but due to some error in logging the information, or right. So I hope you understand how this process happens, right? So whenever you're trying to collect the information, or whenever you're trying to log the information about this particular thing, right? So there would be some team which would be involved in logging all the information about the particular movies in the IMDb data set, right? But because of certain sources of error, we can have missing values, right? So those are very difficult to identify, but in some cases we can understand why those values are missing, right? But that might not be the case for all such scenarios, right? So we'll only be able to prove for some of the cases that why are we getting these missing values. But in this case, we won't be able to actually figure out what was the issue or what went, right? So of course, we'll need to connect with the team who actually produced this particular data set, right? So that's all right, but you need to understand that how we are logging information, and because there are some not foolproof ways to log the information, right? So there could be some pieces of information which are missing, and that is what we denote by NaNs, or missing values, right? So as you can see, home page has around 2000 null values, right? So 946 non-null, that means 2000 null values, right? And then you have IMDb ID, which is 3000 non-null, right? So IMDb ID is the unique identifier uh, for each movie, because every movie has a unique IMDb ID, right? So this is the ID or the identifier which IMDb guys went out to create a unique identifier for each and every movie. Okay, and then you have the original language. So this again has zero null values, and then original title. This again has zero null values. Overview only has 8 null values, and similarly, you can see their number of null or non-null counts and their D type, right? So as you can see, most of these variables are either numeric or object types, right? So in object, we do not only include the string types, but as you can see, we can have, let's say, complicated data structures such as list of dictionaries, something like that, right? So those are also classified as, or they're understood as the data type, or object D type. Okay, so let's talk about a very important method, which is describe. So the describe gives the overall descriptive summary of the data frame, right? And remember, this works only for numerical columns, right? So descriptive summary, as in it gives us certain statistics about the values for those columns. Okay, so let's say if you want to run a df.describe, so what it will output, it will give you the stats for all the numerical columns, right? So you can only find the mean for those columns which have numerical values or numbers, right? And then, so firstly, it gives the count, right? So what's the count of the non-null values, right? So for ID, there are 0 null values. For budget, the same, popularity as well. Runtime, we have 2 missing values. And then revenue is also populated for all the rows, right? And then you have the mean, right? So the mean of ID is 1500, something like this. So it will essentially be, we'll have to explore this, but on average, right? So so the mean is 1500. Okay, and then you have the budget. Okay, so what is the mean budget across all the movies, right? So you have a budget column, and then if you find the mean of all those numbers, so this is what you will get. Okay, and then you have the popularity, and then you have the runtime, right? So mean values for these columns, right? Popularity, runtime, and then revenue, right? So the average runtime of all the movies available in this particular data set is 107 minutes, which is somewhat closer to 2 hours, right? And then you have the standard deviation for these variables as well. You have the minimum value which all these variables are taking, right? So for budget, the minimum value is 0, right? So uh, I don't think it makes sense for a particular movie to have 0 budget. So this again could be due to some sources of error while logging the information, right? So always, because when we're dealing with real world practical data sets, right? So it will not be very well crafted and the perfect data set which we'll be getting, right? So there will be some erroneous pieces of information, and we have to work around with those, right? So you'll need to understand that there could be sources of information in your data set, and we just have to live with it, right? We cannot do anything, because let's say if I was working in IMDb, I could have even gone ahead and try to explore what was the issue in getting the values of budget, etc., something like this. Or maybe if you can, someone tell me why the budget is 0 for let's say some a particular movie or any such movie, right? But that won't be possible, right? So we'll have to find clever ways to understand what's happening, and in cases where we're not able to comprehend what went wrong, so we'll have to just live with it, right? So you cannot do anything much about it, but of course we can do all other sorts of exploratory analysis on this data set, because there are other useful columns which have a lot of meaningful variables and values in fact, sorry. So column is another just word for variable. Okay, and then you have the 25th percentile and 50th percentile. This is nothing but the median, and then the 75th percentile, and then you have the max, right? So as you can see, the maximum run time was 338 minutes, right? So what is 338 minutes? So it's between 5 to 6 hours, right? So there was a movie actually which was more than 5 hours long, right? And you cannot even, and it was not Lord of the Rings for that matter, right? So it was some other movie which was really long, more than 5 hours, right? So this is a basic descriptive summary of our numeric variables, right? Of course, you cannot get the mean or the max for any other data type, but it makes sense for numeric variables, right? So I hope, yeah, you guys understand. So now let's talk about indexing and slicing, right? So let's say you're given a huge data frame, right, or a huge data set, and at times what will we want to do? So we would want to work with a particular slice or a particular portion of our data set, right? So we wouldn't want to work with the entire data set at times. So we'd want to focus on certain segments or certain subset of our data, and this is where the indexing and slicing operations will come in really handy, right? So just let's run the df.head thing. Okay, so this gives us the top 5 rows, and okay, so first indexing method. So this is really important, and I want you guys to pay a lot of attention. Okay, so there is one method which we can use on our data frame to pick out those rows and columns which using indices, right? So you remember from the last class that your rows can have indices and your columns can also have indices, right? So indices and labels are different things, right? So indices basically they start from 0, 1, 2, 3, something like this, 0, 1, 2, 3 for columns as well. But labels are a name for those identifiers, right? So let's say your every observation can have unique dates as identifier. So that date will be a label, but not an index. Okay, index will start from 0, 1, 2, something like that. And then again, you can have the column labels, which are essentially your column names, right? But of course, I can denote the first column as corresponding to 0th index, okay, or in the second column as first index, something like this, right? So there's a difference between index and label. So indexes are simple numbers which are starting from 0, 1, 2, 3 until the number of observations you have, and similarly with you can have column indices. But labels are which denote those particular identifiers, right? So here, let's say IMDb ID can be a very good row label, right? Because it uniquely identifies each and every observation, right? So for every movie, you'll have a different IMDb ID. Okay. So let's talk about the ILOC method. So this gets rows at particular positions in the index. Okay. So firstly, let's talk about just the rows. Okay. So what you need to write, you need to write your data frame name. This is pretty easy. Then you need to write dot. Okay. You need to write dot, and then you need to write ILOC, which is short for index location, or right, which is short for index location. And then you can provide the square brackets, right? So whenever we wanted to provide indices, right, so we're always using square brackets. So here also we'll follow the same thing. And let's say I want to get the first 15 rows. Okay, so first 15 rows, so I'll not specify 0, okay, because it will eventually start from 0, but I'll provide the ending one. Okay, and then let's say I want the first 5 columns. Okay, so maybe I can provide 5, right? So colon 5. So of course you can write 0, you can also write here 0, but of course it always starts from 0, so you don't have to worry about those. Okay, so what this means, so there is a comma, right? So the thing before comma, it denotes the indices for your rows, and then this denotes the indices for your columns. Okay, so the indices provided, or the range of indices provided to the left of the comma, will denote the row indices, and the index range provided to the right of the comma will denote your column indices. Okay, so let's go ahead and execute this particular piece of code. Okay, so this gives you the first 15 rows. Okay, and this also gives you the first 5 columns, right? So 1, 2, 3, 4, 5, right? So this is a very simple way. Let's say if you didn't want just the 5 columns, but in fact all of them, so you can simply do away with comma as well, right? So whenever you are specifying anything as such, let's say without any comma, so that means it will do subsetting on rows. Okay, so here I want to, let's say, select first 20 rows. Okay. All right. So as you can see, so we have first 20 rows, right? So one second. Okay. And then let's say if we want to get all the rows, but only the, let's say, first 3 columns. Okay. So you can write comma, right? And then you can write colon, and maybe here we can provide colon, right? So that means we don't want to pick any particular row, but we just want to pick the first 3 columns, and we want to get the data for all the rows, right? So as you can see here, this particular slice, it gives you 3000 rows, because here we have not provided any subsetting on the row indices. So we want all the row indices, and but we only want the first 3 columns, right? So that's why we have provided colon 3, right? So this is for ILOC method, right, which is short for index location, right? So this makes sense, right? So can you guys please confirm if you're able to comprehend what ILOC does and how does it work, right? It's pretty similar to what you have learned in, let's say, NumPy array, right? So there's nothing too intimidating from the perspective of slicing or subsetting using ILOC. Okay. So let's see if I want to get the last 3 columns. So I can also provide something like this, right? So I can get the last 3 columns too. Okay. So okay. So this is pretty the standard thing, right? Which you already know from earlier. Okay. Then there is another method through which we can do the slicing, or we can get the subset of the data. But here we'll not use the concept of indices, but here we'll use the labels, right? So we can use the row labels, and or we can use the column labels. Okay. So because in our data set, our row labels, they coincide with the indices, right? Of course, we can change them. We can make the IMDb ID as the index. Okay, so we can do that as well, but we'll see that thing later on. But just try to understand that here in this case, if you talk about row labels and column labels, so our row labels, they coincide with row indices, because they start from 0, 1, 2, 3, something like this, right? So they coincide with row indices. But if you talk about column labels, we do have column labels, which are essentially column names, right? Something like budget, the genres, right? Homepage. So we discussed this in the beginning of the class. Okay. So this is the lock method. So here you need to provide the labels which you want to get. Okay. So here, for example, because our row labels are coincident with indices. So here what you can write, so you can write, of course, df, your data frame, and then write dot, which is always we want to do whenever we are calling any method or any attribute related to a particular object. Okay, that is how we perform those operations on a specific data type or object. Okay, you can write lock, which is just for locate. Okay, which is just this short for locate, and here you can provide the range of row labels. Okay, so you can provide, let's say, 50 to 60. So I want to get those rows whose row labels are between 50 and 60, and I want those columns. So here I need to provide the column names, because those are my column labels, right? So I need to provide them in a list of values, right? So let's say I would just want 2 columns which are budget and genres, right? So I can simply provide them. So after comma, right? So after comma, you can provide them in square brackets separated by comma. So essentially a list of column labels we want to get, right? So let's go ahead and run this, right? So here maybe you can also get another column. So maybe let's say runtime. Okay, so runtime is a variable we had, right? So you can see runtime. So this is how it works. Okay, so now let's say you want all the rows, right? But you just want these 3 columns. Okay, so what do you do? Okay, so in this particular case, yeah, just give me a second. Okay, so we can simply copy paste this particular line. Okay, and we can remove the condition from the 50 to 60, right? So here you don't even have to provide the comma or any such identifier. So here what we mean, so of course there is a outer square brackets, and then within the square brackets you are specifying the list of column labels. Okay, so this means that just locate all these column labels and get fetch me all the rows, right? Because I am not providing any condition before comma, right? So of course if you just do this, it will fetch you all the rows, right? It will fetch you all the rows, as you can see, 3000 rows and 3 columns. But even if you don't do that, it will again, yeah, sorry, maybe a particular thing. All right, so here we don't need okay, just give me a second. Okay, so this gives you all the rows, and if you just want the 3 columns, so what you can do, you don't even have to write the log thing. Okay, so in the log, let's say if you want to have all the rows, so you can provide the colon. Okay, and this will fetch you all the observations. But let's say you don't want to use, you want to get the 3 columns but without using the lock or ILOC method. So here you can simply write df, and then you provide the outer square brackets, and then within those square brackets you specify the list of column labels you want, right? So here let's say I want to get the original language, release date, and the cast. Okay, so this we can do, and yeah, this will make sense, right? So we are getting all the 3 columns which we want, and yeah, we're getting all the rows, right? So you saw that there are different ways. So of course you can subset a data using the ILOC method, which is index based location, and then you have the lock method, which is just label based location. So let's say in our data set you have row labels, let's say such as dates or maybe the IMDb ID. Okay, so we had this IMDb ID, right? So this can be your row label. So there will need to provide those conditions on row labels for what we want. We will not be able to work with 50 and 60 when we are making let's say IMDb ID as the row labels, and this will not work with lock method, right? So I hope you guys understand the difference between indices and labels. Can you please confirm if you are able to understand what's the difference between indices and labels, right? And are you, if you are able to understand how, what's the difference, basic difference between ILOC and lock, right? So ILOC does your slicing using the indices, but log does your slicing using the labels, right? So what are these in, so in ILOC you have your row indices and the column indices, and then of course when you're using log you can use your row labels and the column labels, right? So essentially what are these labels? So these are those labels which identify unique observations, right? So that's why we have need for these labels in a way. Okay, all right. And then of course we saw that we can get all the 3 columns we even without bothering, yeah, even without bothering about the log or ILOC, right? So we didn't even have to provide, and we can get all the rows in this particular fashion. Or maybe let's say I want to get the first 5 rows. Do you think this will work, right? So here also, so this is nothing but a data frame. Okay, and then in data frame also we can provide this particular thing, right? So 0 to 5. So here we didn't even need to provide write the log ILOC thing, right? So this we can do, and in fact let's say let me just add another piece of code. So let's say I want to get the first 5 first 10 rows. Okay, so you can see we can get the first 10 rows simply by just writing this particular tiny thing, right? So without even using lock and ILOC method, but those will be important, lock and ILOC, when you want to use the conditions on, let's say, both your row indices or row labels and your column indices or column labels, right? So they will be really useful. But I was just trying to give you an idea that we can also get the first 10 rows simply by just writing this particular small tiny statement. Okay, so Chitranjan is asking, does slicing work with name labels or columns? Yes, so that's what we did, right? So here we provided the column labels only, right? So we provided the column labels only, and it worked, right? Okay, so here also when you run this particular thing, Okay, so you write the df, and then within the square brackets you provide the list of column labels you want. So this will be a data frame of size or shape 3000 rows and 3 columns. And then if you want to get, let's say, the first 100 rows, right? So you can simply do 0 to 100, and yeah, this will give you those particular things, right? Okay, so let me see what's the question. Chitranjan is asking, so line, budget, title. So is it necessary to pass it a list, or can we just use column names? Okay, so let's see. I'll try to answer your question. So the best way to do the experimentation, and what do you think? So what does your gut tell you, right? So can we even use, right, these things, right? So it says a key error, something like this, right? So you need to provide the list of column labels, right? So I hope you get your answer. Yeah. Okay. So you need to provide the list of labels there. Okay. All right. That's great. Okay. Let's move ahead, and we'll try to yeah, do a lot of things. So firstly, yeah, so let's talk about Boolean indexing. So we can perform Boolean indexing, as in we can put certain conditions on certain variables, and only get those a subset of data, right? So consider one example. So let's say, so in our data set we have a mix of movies whose original languages are different, right? So there are English movies, there could be French movies, there could be Korean movies, or maybe Hindi movies too, right? So let's say if we want to get the English movies, right, so how can we get the data for only the English movies, right? So maybe let's say you have 3000 movies in total, and English movies could be around, let's say, 2000, right? So how do we get those 2000 movies? So we can simply yeah, create that particular English movie data frame using this very simple sweet statement. So here we'll write the name of the data frame, right? And then we'll provide the square brackets, okay? And here we'll provide the Boolean operation, or the Boolean indexing, right? So if you remember, right, so this gives you the list of Boolean values for all the rows, right? And for all those observations for which this particular Boolean expression yields the value true, those particular rows are taken. Okay. So here what I'm specifying, so I'm specifying df, and then original language is equal to English, right? So this is the value. So if you just let me just run this, right? So this will give me all the movies whose original language is en. Okay, so of course I have printed the head, but you can in fact check for all the observations for this particular data frame, which I'm calling as English movies, and yeah, you will be able to verify that yeah, this worked. Okay, so it's a very simple statement. So you just need to write df, and within the square brackets you need to provide the Boolean expression, right? So essentially what this does, right, so if I just run this particular piece of thing, right, so you'll be able to see what I mean, right? So maybe if I write, right, so for all the indices, right, so it returns either true or false, right? So for whatever rows, if this value is true, those observations are taken into consideration. So this is essentially a list of Boolean values, and it's only picking those particular observations, right? So are you able to understand how this Boolean indexing is working? Can you please confirm over the chat? uh, yeah, so it's it's a relatively straightforward, right? So this is how we can do Boolean indexing. Okay, so essentially we'll try to get the Boolean for all the rows satisfying the condition, right? So if that expression is satisfied, so the Boolean will be true, or else it will be false, and only those observations will be taken in our slice for which that operation returned true. Okay, or our Boolean expression is true. All right. So maybe let's say I want to get all those movies whose runtime is greater than let's say 100 minutes. Okay, so this is where I have written the condition. So maybe I can add one condition. So let's say long movies. Okay, so we are not doing any such thing. So df and then df, and then you can provide runtime. And as you can see, so this thing, right? So here now this thing has to be greater than, let's say, 100, okay, or maybe 120. So any movie which is greater than 2 hours, so I will call that a long movie. Okay. So let's go ahead and run this, and maybe I can print the head of long movies, or maybe I'll just do it this in this set. Okay, right. So now this has executed, and I can see what are the long movies. Okay, so dot head, right. So here now, if I scroll to the right, so as you can see, all the runtimes are greater than 120, right? So 145, 122, 130, 125, right? And of course, you can explore the tail, and in fact, you can go through each and every observation just to verify if this is working or not, right? So as you can see, 149, 129, right? So you wouldn't find any such observation for which the runtime takes a value less than 120 or even equal to 120, right? So this is what we have provided as a Boolean expression, right? So this yields true for all those movies which have the runtime values greater than 120, right? So that's great. Okay. I think Raj, you have Rajat, you have put an extra bracket in the right. Okay. So there will be only one single uh, square bracket in the right. Okay. So now, what if I wanted not only the long movies, but those should also be English, right? So now we have two conditions, right? So the movie should be of original language English, and the runtime of that movie, let's say, should be greater than 120. So how can we do that? So here also, you can run this particular statement, and I think you can verify, right? So let's see if I run this particular thing. Okay, so you can see that I am getting false for some rows, but there will be some rows for which there will be a true condition. Okay, okay, so let me just, okay, all right. So how do we now get all those movies which are not only English, but they're also lengthy movies or longer movies, right? So here we'll write, of course, df, and then we will have the usual square brackets, and then within the square brackets we'll write this Boolean expression, right? So I hope you guys are aware how we can write two Boolean expressions together. So remember, we have an and operator, so both the conditions should be satisfied. Okay, so the movie should the original language, right? So this is the first condition. This is the first condition. So df original language is equal to en, right, which is English, and df runtime greater than 120. Okay, so I provide them each condition in parentheses just to be safe, so that I do not get confused between multiple operations, right? So you can have multiple conditions here, right? So not only English movies and not only lengthy movies, but let's say movies which are of genre comedy, of comedy genre, right? So okay, so right, so we can use the ampersand here, that it totally works, right? So you don't have to worry about this particular bit. Okay, so and totally works. Or maybe let's say if you want to have or conditions, you can have a pipe here. Okay, so these both are supported. Okay, so let's go ahead and run this. So as you can see, so it will only give me those movies which are English, and their runtime is, as we can see, their runtime is greater than 120, right? So this is how we can use Boolean indexing for, let's say, two columns to get a particular slice of the data. Okay, so I hope this makes sense. Okay, so maybe so someone is suggesting, can we use and? So let's see if this works, right? So here we need to write ampersand. Okay, and this will work fine. All right. So yeah, so I hope, yeah, you guys are able to understand. So here what was our objectives? Our objective was to understand how can we subset the data, let's say using two columns or conditions on two columns, right? Yeah, give me a second. Okay. Now, yeah, moving ahead. So this is all about how we can slice our data. How can we get this subset of the data based on our whatever requirement we have. So let's say if you wanted to get any particular movie, let's say maybe let's say movies which were released after 2000, right? So you can put those conditions and yeah, you'll be able to work with them, right? So I hope, yeah, you understand this basic idea how we can subset the data. So we saw a lock method, ILOC method, and then we can also use Boolean indexing to get those particular uh, observations which we want, right? So okay, now let's see how we can manipulate columns. So by manipulating columns, what I mean, so how can we rename the columns, or how can we drop the columns, or maybe add another column? So those things we should be able to do, and Pandas provide a variety of handy functionalities which will make our life quite easy. Okay, so let's say I want to create a column, right? So add new column whose runtime. So add a new column where which is just half the total runtime. Okay, so I'm creating. So what I'm doing, firstly, I'm not so I'm writing df, and then writing the new variable name which I want to create, or new column I want to create, right? So this does not exist in your data frame, but we want to create a variable, and I'm calling that variable as half runtime, which will just be uh, half of the runtime which we have originally in our data frame, right? So we want to get a new column which will essentially have values which are just half of these, right, for all those movies, right? So how can we do that? So firstly, so we need to write this particular bit, right? So this is the column. So this is how you identify a particular column, right? So you remember, let's say if I write df runtime, okay, so this gives me all the, right? But let's say if I wanted to add something else, maybe genres, so would I be able to get it, right? So I won't be able to get it, right? So when you are having at least two column labels, so you need to provide the square brackets, right? So you need to pass the list of yeah, right, list of labels, right? So this works. Maybe I can just run it again, right? So this works. But let's say if you're just focused on one particular column, so you don't have to specify that within a square bracket, so you can simply write runtime here, right? So this will give you all the observations for this particular column, right? So as you can see, so this is of length 3000, and this is nothing but a series only, right? So remember, last year we learned the concept of series. So this is a series essentially. Okay. Okay, so now what we want to do, we want to create a new variable whose values are just half of the total runtime. Okay, so we'll write this particular bit. So df, and then within the square brackets, we'll write the new variable name which we want, or the column which we want to create. And then what we'll do, we'll write the column name whose half we want to get. Okay, so we'll write that particular column name and then simply multiply that by 0.5. Okay, so we don't have to do it in a loop or separately for every row, right? But we can simply multiply this 0.5 to this entire series. Okay, so let's go ahead and run this. Okay, so now as you can see, if I scroll to the right, okay, so now we have a new variable which is half runtime, and as you can verify, so half of 93 is 46.5, half of 113 is 56.5, right? So we have got a new column, half runtime, which is essentially whose values are essentially just half of your runtime. Okay, so this is how you can create a new column simply, right? If you just wanted to do this basic operation. Okay, of course we'll need we can use complex constructs to create different new columns using different conditions. Okay, so now let's say I want to create a new column, let's say, which I'll call as movie profit. Okay, so this movie profit will essentially be the difference between the revenue generated by that movie and what was the budget of that movie, right? So budget as in what was the total cost it incurred, or the total cost incurred by the production house, and how much revenue they were able to generate, right? So that the difference of these two will give us the profit. Okay, so let's go ahead and create a new column which is movie profit. So here also we'll write df, and then within the square brackets we'll provide the movie name within quotes. Okay, because these are string, so you need to do that. And then you provide the first column, right, and then the second column, right? So essentially for each row, our movie profit will be the value of revenue for that row subtracted by the budget for that particular row. That means for that movie. Okay, so let's go ahead and run this. Okay, now as you can see, if you just explore the data set by calling the head method, so now we have another new column which is movie profit, and this is simply the difference between your revenue and the budget. Okay, so this is how we can create a new column using existing columns. Okay, so let's say if I want to multiply two columns or subtract two columns or add two columns, so we can do that in a very fairly simpler way, right? So we just need to write this particular bit, right? So it will eventually do row wise calculation and create your new column. Okay, so guys, are you able to comprehend how am I getting these new columns, right? Okay, so let me see. Yeah, please let me know just quickly, everyone. Yeah, showed your concern. Okay, so I think yeah, everyone understands how we are creating a new column. Okay, so this is very straightforward, and as you can see, the syntax is really easy, right? So that's why Pandas is such a easy and intuitive library, right? So you can play around with these things. Maybe let's say if you don't even know how to do this, so you can simply Google, let's say, uh, subtract two columns, maybe, and then you can write Pandas, and I can also write stack over, right? So we can subtract two columns in data frame, right? So you can simply see, yeah, this particular line, right? So whenever you are facing any such difficulty, so you should be able to do this, right? So remember, we learned this basic functionality when we're discussing about NumPy arrays, right? So there we can have element wise subtraction, multiplication, division, etc. So because Pandas is built on top of NumPy, that's why we are having these flexibility, right? So whatever we are running here, it's essentially everything is being operated using NumPy arrays, but because Pandas is much easier to visualize and realize, because we have these row and column identifiers which are calling as indices or row labels or column labels, right? Okay, that's great. Okay, so this is how we create a new column, and then let's say I want to drop a column. Okay, so how do I do that? Okay, so it's fairly easy. So I can write the data frame name, and then of course dot, and then there is a keyword which is drop, right? So this is short for dropping columns, right? So let's say you don't know how you can remove one column or drop one column from a Pandas data frame. So again, you can simply Google search it, right? So as I have been telling over the last 2 days, you just need to have this awareness that yeah, this is possible. This is what we can expect Pandas to do, right? Something like, can we remove this column? Okay, so you can search remove a column in Pandas. Okay, so you can simply search this, and maybe you can add Stack Overflow for more better search. Okay, so Pandas Stack Overflow. Okay, so how to drop column in your data set with Pandas. Okay, so here now you can see that yeah, it gives you that particular index, and in fact statement. And in fact, you'll have a lot of so how to delete a column from a data frame with Pandas. So here also you can see So maybe, yeah. Okay, so a drop, right? So there's a drop thing, but of course you can Google these things, right? These are pretty common, and of course you can consult the original Pandas documentation. So remove a column in Pandas, right? So it shows you pandas.dataframe.drop, right? And as you can see here, you have all the details, and then of course a working code as well, right? So here they want to drop two columns, and then, right? So this is how we do it, right? So one more thing which you need to understand is the concept of access, right? So here what I'm saying, df dot drop, and then of course whatever columns you want to drop, so you can provide them within the list. If it's one column, you can forget about the square brackets. But let's say if there are two columns or three columns or more than two columns you want to drop together, so you'll need to provide all those column labels in a in the square brackets, right? So you need to pass those list of column labels. Okay. Now axis is equal to 1. What does this mean? Okay, so this means that we'll do this for all the columns for each row, right? So essentially what axis 0 and axis 1 means, right? So I can tell you guys, right? So let's say you have this data frame, right? So essentially what happens that axis 0, it runs in this particular fashion. Axis is equal to 0, sorry, right? And then axis is equal to 1, it runs in this direction. Axis is equal to 1, right? So you don't have to worry much about it. You'll get to understand this particular thing when we work our way through different examples, right? But for now, just keep in mind that axis is equal to 0 deals with all the rows for a single column, and then axis is equal to 1 deals with, let's say, multiple columns for a single row. Okay, so here what I be saying, just let me just clear this. So what I will be saying here, so drop this column, and we have provided the axis is equal to 1, as in let's remove this particular column. Okay, so this is how we write it, right? This is what we mean by axis is equal to 1, right? So if you want to, let's say, focus on a single column, so that means axis is equal to 1. Okay, so you don't have to worry or confuse yourself. We'll work our way through examples, and this will become clear, right? So we'll be using axis in a few other examples, and the concept will become clear. Okay, and then of course you have in place is equal to true, right? So this is important because you don't want to write something like df is equal to something like this, right? Of course you can do that, you can do this, but it's a very standard convention to write in place is equal to true to invoke the change by this method in this data frame. Okay, so that's why we write in place is equal to true. Okay, so so people are a bit curious, so maybe I can provide axis equal to 0, and maybe you can understand what this right. So it says that id not found in axis, right? So this particular id is not available in the axis 0, right? But it's only available in the axis 1, right? So when we are moving across columns, so that there we can encounter this particular id. But let's say if you're moving across rows, we won't be able to locate this particular id bit, right? Because it's it's not present along that axis, right? So id label is only present along the column side, right? So I hope you guys understand this, but of course I'll come back to this particular bit in just a while, so you can keep experimenting with this. Post your questions and I'll try to answer them. Okay, so moving ahead. So now let's say if you want to drop multiple columns at once too, so how do you do that? So you can write df.drop, and then of course, because we want to remove multiple columns, so of course we will be providing the list of column labels. We'll write axis is equal to 1, and then in place is equal to true. What this means that these two columns will be removed. That means whatever the effect of this particular method will be on this data frame, that will be invoked in place, right? So our data frame will get changed, right? So here we remember we removed the id column, Now if you see, right, there is no ID column, right, because we dropped that particular column. Now let's say I want to drop these two columns, half runtime and poster path. Okay, so let's go ahead and run this particular cell, and now we can see that we don't have a poster path or half runtime, right? So remember, we created this variable half runtime, but it's not available. Okay, so all right, so in this way you can drop multiple columns. Maybe there is a question, so of course these are just experimental questions, right? So let's say if I want to remove the column, maybe let's say, which column do I want to get rid of? Maybe crew. For now I don't want crew. So someone is suggesting let's put we don't specify the access. Okay, so let's see if this works. Okay, so right, so it does not work because crew not found in access. So you need to define the access where that particular label will appear, right? So this label will appear in access is equal to 1. Okay, so you can specify access, or you can also specify directly corresponding access. Okay, and yeah, this should work. So of course you can read the documentation here, right? So remove rows or columns by specifying label names and corresponding access, or by specifying directly index or column names. When using a multi-index, labels on different levels can be removed by specifying the label. Okay, so we need to, in this particular case, we need to define the access, right? So remember, if you try to simply run this, so it will just give you this error, crew not found in access, right? So here we'll need to provide access is equal to 1. Okay, for now, just don't worry about the concept of access. This will become clear in a few examples. Okay. Okay. All right. So actually, I'll admit that the concept of access can can get trickier, right? Because you're not sure, do I need to consider all the rows for a single column or all the columns for a single row? I'm just totally confused, right? So all these questions can come in, especially when you're new to this. But the more you work your way through the Pandas utilities, these things will become pretty clear, right? So now let's say I want to get the sum of a particular column, right? So let's say I want to add all the values of a particular column, and of course that makes sense for a numerical variable only. So we have this budget, which is a numerical variable, and maybe what we can do, we can find the sum of all the values in our column budget. So let's go ahead and do this. Okay, so this is what we get. Okay, also what you can do, so you can set a particular value to null, okay, or a particular series values to null. Okay, so let's say what I want to do, okay, one more thing you guys might not have noticed. Okay, so let's say if I write ILOC :3, and maybe I don't specify anything here. Okay, so this gives me the first 3 columns. Okay, or right now let's say if I write df.lock then 3. Okay, so now this gives me 4 rows, right? So when I did ILOC and I wrote :3, right, so it only gave me 3 observations, right? Because here it's treated as an index. Okay, and whenever we are talking about index, the rightmost index or the element located at the rightmost index is not included in this slice. But here we are using the locate, and when we specify :3, that means it's the label. Okay, so it is the label :3, and it will get you all the observations till that particular label. Okay, so this is not an index, but in fact label in this case, right? So I hope you guys understand the difference between the ILOC and lock, right? So this is a very minute thing, but more often than not it gets overlooked, right? So are you able to understand? this tiny difference between ILOC and lock. Okay, Smruti, I'll just repeat this particular thing. Okay, so in ILOC, you're providing the range of indices, right? So here, whenever we have been doing slicing using indices, we have been always been telling that the left index is always included, the right index is not included in the slice, right? So this is what we are seeing when we are using ILOC method, which is based on index, right? So here, as you can see, we have only have 3 observations, 1, 2, 3, right? But when we use lock, which is based on row labels or column labels, it is not concerned with indices. But because in our data set, the row indices coincide with column labels, so we have the same values, right? So here the labels, what I'm providing as :3, that means 0 to 3. So here, what will happen that here instead of 3, we are getting all the 4 rows, right? So 0, 1, 2, 3, right? So this is not excluded. This is included here because when we are using the lock method, that means these are the labels, and that particular exclusion thing only works with indices, right? So does that make sense? Okay. So it makes sense, right? So you say that I want rows with these labels, and but if it, let's say, do not include that particular label, right? It does not make sense. I hope you guys know this particular thing, right? So why that rightward or the right index or the element at the right index is not included in the slice? It's because your indexing starts from 0. So let's say whenever I write something like a :3, because indexing starts from 0. So what happens in this case? We will be getting 3 columns only, or 3 rows. Sorry, we'll be getting 3 rows or 3 elements, right? And this is not included, right? So it makes sense because indexing starting from 0. So it looks very natural, right? So when you write 5, so it will give you 5 rows. But of course, what are the indices for those rows? So 0, 1, 2, 3, 4, right? So yeah, that is it. Okay, but when you're providing labels, right? So there, Python cannot use its own discretion. It can only understand what you're asking Python to do, right? So you're saying that, let's take all the movies which have been released between, let's say, January 2000 or 1st January 2000 to 1st January 2021. Right, so it cannot use its own discretion to remove one particular observation from the end, right? So that does not make sense. So whenever you are using the lock method and we're providing the label ranges, so all the observations will be included, right? I hope this makes sense, guys. Yeah, does this make sense, everyone? Okay. So Sumant is saying I could not able to understand lock. Okay, so lock is again a way of slicing or subsetting our data, but here we are not using the indices, but we are using the row labels or the column labels, right? So in your case, right, so let's first set the indices to something else, or row labels to, in fact. So what I can do, I can set a particular column to as an index. Okay, so how do you actually search for that? So set a column in Pandas. So set a column as index Pandas. That is what you just need to do, right? So here we just need to copy paste this particular code, and here let's see, we'll try to do this particular task. So here we have df, and then I want to make IMDb ID as index. Okay, so let's go ahead and do this. So now maybe I'll just move this particular cell below, right? So now let's see how our code looks, how our data frame looks like, right? So now, as you can see, IMDb ID is your unique identifier. Okay, so maybe let's say if I try to run this particular bit, right? So you can see that cannot do firstly I'll not run lock, I'll try to run ILOC, and let's see if that works. Okay, so let's run this particular thing, right? So this works, right? So this gives me the top 3 rows, right? And you can see that IMDb ID is the unique observation, right? So you can set a particular any column as an index, right? If that particular column is suited for an index, right? And the idea of index is to have a unique identifier for each observation, especially when you're talking about row indices. Okay, now here if I try to run this particular thing, right? So here it says that cannot do slicing, or maybe I'll just remove revenue, right? So you can see that cannot do slicing, uh, slice indexing or index with these indexers of type int, right? So here we'll need to, let's say, provide these maybe list of values. So maybe this particular thing. Okay, what about this particular bit? Okay, so I can also provide this here. Okay, now let's see if this works, right? So now it gives me those 2 rows which are corresponding to these row labels, right? So lock is essentially concerned with row labels. Earlier in our case, the row labels were coincident with the row indices, right? Because the indices will also will always start from 0, right? If you talk about row indices or the column indices, but when you talk about row labels, so those row labels can be anything, right? So it can be here in this case some ID. Let's say for some other data, it can be a date, time, right? Anything, right? For example, transaction data. So DateTime stamp could be a row label, in fact, for that particular data set. Okay. Okay, great. Sumanta, can you please confirm if you're able to understood? If you're able to understand, yeah. Okay, okay, perfect. Okay, so let's move ahead. Okay, so now we can, of course, we're talking about basic aggregation operation. Let's say if I want to get the sum of values across a particular variable, and of course this makes sense for a numerical variable only, right? So we can write df runtime.sum, and let's say I wanted to find out the something like I can simply write the shortest movie length is, and here I can write something like the largest movie length is, right? So here what I'm writing, so within this square curly braces, right? Remember the f string which we have been using to print our variables. So here within the curly braces, what you can write, so you can write this particular variable which is df runtime, and then you can call this min method on top of this variable, which will calculate the minimum value across all the values of that variable. And similarly we can get the max, and yeah. So as you can see here, the minimum, the shortest movie length is 0 seconds, which do not make sense, or maybe it would make sense if that movie was not released at all. Okay, so there would be some definition to understand, or some way to understand what is the meaning of runtime 0, okay, or 0 minutes. What is the meaning of that? So there could be some movies which were not released, and that's why there was no such information about them. So they were, let's say, kept as 0. But it could be something else. It's just my hypothesis. But of course, you're free to make your own guesses here, right? And the better guesses you are making, and the more educated those guesses are, I think, yeah, you will be doing really good in terms of doing a wholesome analysis of your data set. Okay. Then let's say I want to get all those movies with runtime 0. Okay. So maybe, so what I'll do, I'll write this Boolean indexing operation. So df, and then df, I'll put the condition, right? So, okay, so let's see which are the movies with, okay. So which are the movies with 0 runtime? So as you can see, runtime is 0, but as you can see that most of these movies, they have been released, okay? They've also generated some revenue, but of course, it could be due to some issue, right? Or maybe it means something else, right? So we'll need to explore the data, right? So Sheesh Verma is saying that, yeah, but it can be possible. Exactly. Right. So there is some erroneous information here, but we need to understand how this might be coming from so that we identify. Yeah. So Sanjita is definitely, are you correct? So there could be some error while logging the information, right? Or while entering the data, right? So these things can happen because not everything is foolproof, right? So everything is essentially made by humans, even if you talk about computers, anything. So nothing is foolproof. So they might have created some sources of error, and that's why we are seeing these weird values which do not make sense, right? But let's say if some people uh, imputed these values as zeros uh, due to some reason, I don't think, yeah, at least I'm not able to figure out what these values actually mean, right? So maybe if these people provide the data dictionary, or maybe some information about how the data transformations were carried out, or how the data was collected and prepared, right? So maybe we can be successful in understanding what's happened, right? So Rishabh is saying data handling team is not good enough of IMDb. I would not say that, uh, because see, I think these movies. Let me see about this particular movie, right? So this was released in 22nd December 2012, right? And there could be some issues. Okay, so this was a Russian movie. Uh, Something, there could be some details or some other pieces of information which we can exploit to understand what went wrong here. But as a data scientist, you'll often encounter such uh, pieces of information which can seem totally erroneous, right? So you have to use your best judgment, and you have to use your wise discretion to understand what's going underneath, right? So these things are at your discretion, and the better judgment and the better explanations you are able to come up with, that means you have more understanding of the data. Okay, so exactly, might have had problems before certain dates. Of course, we can explore these all the observations here, and I think how many rows are there? In fact, so there are only, I think, very few observations with zero uh, runtime, right? So it could have been, even it could have been a typecasting error, or maybe formatting issues, right? So those values were, let's say, populated with something else, but when some formatting was applied or something like that, they got changed to zero. It might happen, I'm just guessing, but there could be different reasons, and of course you'll need to explore all these observations to have a better understanding of what happened, right? So but if you think about, so most of these movies, so they are not of English language, right? So it is Italian, RU, which is Russian, then Spanish. Yeah, this is Spanish, and then Italian, Russian. So there's of course one English movie, but again, uh, right? So okay, so there could be some issue, but yeah, most of them are different languages, different language movies apart from English, but there are some English movies. Okay, so yeah, let's not bother about it. Of course, yeah, this is just one data set. Yeah, you want to work with, right? So right, so this is the least erroneous data. So Rishabh is saying a data scientist can get exactly. So the real world data can be a lot shittier. Okay, so uh, yeah, be prepared for that, especially if you want to become data scientist, right? So you'll be spending around 60% of your time working your way through the process of cleaning the data, obtaining the data, yeah, trying to come up with very yeah, smart, essentially very clean set of features or clean data, right? So those things, yeah, that's essentially what 60% of what a data scientist does, right? Because if you want to apply any ML algorithm, it's just two lines of code, right? So one is of course fit, and the other is dot predict, right? So these are the two lines if you want to fit a machine learning model. But most of the time you will be spending on cleaning the data and seeing what are the issues with it, right, etc., or doing feature engineering, as in coming up with new variables. So those things are there. Okay. So now let's talk about another very important method through which we can create a new column. Okay, so we saw earlier how we can create a new column just by doing some arithmetic operations on two columns, right? Because that was possible because the pandas operations are in backend happening with numpy arrays only, and they support those functionalities as we had discussed in the numpy class, right? So let's say what I want to do, I want to capitalize all the characters of in the available in the title, right? So I want to do this particular task. I want to convert lowercase to uppercase. Okay. So I'm writing first a function which is to uppercase, and this will take a column as an input, and then it will not a column per se, but a value of a column. In fact, a row for that column, and then convert that value to upper, right? So this will be a string, and then we can apply the upper method to that string, because title is this value is nothing but a string only, right? And we can apply this upper method to convert that to uppercase. Okay, so let's run this function. Now you can create a new column which I'm calling as capitalized title, right? So this is what you're familiar with already, and then you can write df title, and then what you can write dot apply and this function, right, which is to uppercase, right? So here you don't even need to provide the argument here, right? You don't even need to provide the argument, because it's understood that this operation or this function will be applied on this particular column across all the rows, right? So essentially what's happening here, so this function is, so this is the column which you are working with, okay, and this function will be applied on each of the rows in this column, right? So on each of all the observations we have available in our data frame, right? So row wise all such apply thing or this function will be applied, and we'll be getting the corresponding capitalized title, right? So let's go ahead and run this. Okay, and let's see. Okay, so now let me just scroll to the right. So as you can see, this is the new column which we have, it is capitalized title, and as you can see, all the characters are capitalized. Okay, so all right, so this is how we use the apply method to apply a function to every row in a pandas data frame. There's another way to do this, so I can write that as well. So maybe I can write another column name, maybe let's say upper case title. Okay, what you can write, so you don't even have to specify, let's say, title earlier, so you can provide apply. Okay, and then what you can write, so you can write to uppercase, right? So and then you can basically I have already included this example later on, so maybe I'll come back to this specific bit later on, because I've already included that elsewhere. So just don't worry about it, right? So here, as you can see, so we didn't even but I'll tell you how that works. Okay, so for now we'll just learned about apply method, right? So how apply method works, so it essentially applies a function to every row in a pandas data frame, right? So what should be the argument here? So argument will nothing but a string. Okay, because essentially it will go to each row, take that value, perform this or apply this function on that value, and return that and store that in your series, right? So this is your column which is a capitalized title. Okay, now let's talk about another useful function, which is lambda function, right? So a lambda function in Python is a small anonymous function. So there is no name of this function. So this is a small anonymous function. A lambda function can take any number of arguments, but can only have one expression. Okay, so what this means, so for example, so we can write, let's say if you want to add two numbers, right? So usually what you would do, right? So you can write add two numbers, something like this, right? So it will have two numbers as input maybe, and what you will return, so you'll return a plus b, right? So this is the way you write a normal function, right? So here of course you need to specify the name of the function, right? but the lambda function helps us create anonymous function, so we don't have to even write the name of the function, right? So how can we do that? So you can write something like x is equal to, right, so this will be your function only. So x is equal to lambda a comma b, and then you can write colon a plus b, right? So this is the expression which you want to provide, right? This is nothing like this, yeah, similar like this, and then you have these two arguments, right, which is same as here, right? So lambda, you write the keyword lambda a comma b, and then colon, and then you write whatever you want to return. Okay, so here uh, uh, we can pass these inputs. So we have stored this lambda function in x, and then we can pass 1 comma 2, and this will give me 3, right? So you can change it to, let's say, 5, so it will give you 6, right? So this is a anonymous function. So one important property of lambda function is that it can take any number of arguments, but it can only have one expression, right? So it can only have one expression, right? So let's see how we can use lambda function in our case, right? So maybe also, right? So you can write something like, right? So let's say lambda. Sanchita is yeah, asking a really nice question. So is it like list comprehension but for functions? Similar, I wouldn't say it's like that, but the idea is a lambda function is essentially a nameless function, right? So you don't have to provide the name of that function, and it will do its task as asked. Okay, so let's take an example. So here I am writing a function which is def revise profit, right? And how this will be used, how this lambda function will be used in our case, so it will become clear, right? Of course, this expression can of course have reference to some other function. Okay, so this particular operation, it could be something like, let's say, sum of a and b, right? Something like this, right? So here you can have different function, but the idea is you can only have one expression. Okay, so here we had a plus b. So let's go ahead and we want to create a new column which I'm calling as revised profit, right? So if revenue is greater than 0, so my new profit will be revenue minus budget, as their word, right? But if revenue is let's say less than or equal to 0, so that means new profit is equal to np.nan, right? So this is a basic transformation I want to apply. So if the revenue is positive, so profit will be, or new profit will be revenue minus budget. But if the revenue is less than equal to 0, right, so there we don't have the idea about new profit, and I'm setting them to NANs. Okay, and then I'm returning new profit. So let's go ahead and execute this particular function, which is a revised profit. Okay, so now I want to create a new column which essentially does this basic task. Okay, so of course what you can do, so you can use lambda function, but of course similar to earlier, we can use a simple apply in this fashion as well. We can run that particular code. Okay, so let's see how we can use the lambda function here. So you of course write the name of the new variable or the column which you want to create, then you write the data frame. So here we are not writing the column name earlier. Okay, now we'll write dot apply. Okay, now in the lambda we'll write the lambda keyword, we'll write x, which is, so here x will essentially correspond to a single observation. Okay, x correspond to a single observation, and then we'll write colon, and then we'll provide the expression for the lambda function, right? So what is the expression? So expression is nothing but this basic function which we have written earlier here, right? So what are the two arguments this particular function takes? So revenue and budget. So here, because x is your entire row, so we can write x revenue, and then we can write x budget. Okay, and yeah, we can enclose this function within parenthesis, and then you write axis is equal to 1, right? So because here you are saying that apply whatever lambda function or method you have, apply this on data frame, right? So it can be applied, let's say, row wise or column wise. So if you define axis is equal to 1, that means what will happen, this particular operation will happen row wise, right? For each and every row, these two values will be taken and corresponding operation will be done and this particular value will be returned, right? So let's go ahead and run this, and now we can check our new profit. Okay, so now we can check our new profit, right? So this wherever revenue is NAN, so for which will not be getting any new profit value, that will just be NAN, right? So wherever revenue is less than 0 or less than equal to 0, our new profit will be null, because this is what we have defined in our function. Okay, so I hope you guys understand. So I'll just reiterate what I've done here. So here, why did we feel the need to write axis is equal to 1? Because we are calling the apply method on the entire data frame, right? So we need to specify which axis we want to work along. But let's say earlier here, we have already specified this particular column, right? So that means, yeah, this will be applied for all the row for this particular column, right? So here we didn't need to specify that particular bit, okay? But because here we are calling the apply method on the entire data frame, and Pandas actually needs to know which axis do we want to work with, right? So of course I can, let's say if I were calculating the mean, right? So I can calculate the mean along, let's say, one column, or maybe I can calculate the mean across all the columns for each row, right? So I hope that makes sense. So here, when I say axis is equal to 1, that means all these operations are happening for each row. So all those values are taken and they are added together, and then the corresponding result is stored in this variable new profit. Okay. Okay. So Shubham is saying, how does Python know whether to add or subtract in Lambda function? Right. See, Lambda function has an expression, right? So this expression can be anything, right? So it can be any function which you have written, right? So here we're using that concept only, right? So revised profit is a function which we have written, and this is the expression essentially for this Lambda function. And this Lambda function is taking the argument as the entire row, right? X here means the entire row. Okay, so that's why we are able to access revenue from X and the budget from X. Okay, we can in fact access all the original title over popularity, etc. Right? So here X means X means a single row, right? And whenever we are using the apply method, it applies this particular, let's say, operation which I'm defining through Lambda function through all the rows. Okay, so yeah, we can do it other ways, but I was just wanted to demonstrate the concept of Lambda function. Okay, so of course we can do this task without using without even writing Lambda. Okay, so I want you guys to figure out how you can do that, right? So you can take a hint from this particular use case, right? So try to figure out how you can implement this particular function without introducing the Lambda word or Lambda function. Okay. Oh, all right. So moving ahead, so we can also sort our data frame by some column values in either ascending or descending order, right? So if you guys have worked with Excel sheets, right? So there you have a option to filter down the values, right? So let's say I want to sort the movies based on their runtime, right? So I want to have the observations in a descending order of runtime. Okay. So what I can write, so I can write df dot sort values, then the column name on which I want to sort, and then I can specify this argument which is ascending is equal to false. Here remember, I'm not specifying in place is equal to true, so it will not change the df, but it will just print the observations in descending order of runtime. Okay, so let's see if we are getting indeed the same thing. So let's look at runtime. So as you can see, the highest runtime movie is appearing at the first, then second, and similarly the bottom, the last ones are 0. right? So, and then of course, you can sort the observations not only on single variable, but you can use multiple variables. So let's say I want to sort the observations firstly in, let's say, descending order of runtime, but also in increasing order of new profit, right? So I hope you guys understand how we can do such sort of sorting uh, using two columns. What does it mean, right? So here ascending, so I can provide it a list of Boolean. This means false for runtime, that means descending fashion, but for new profit it means true. Okay, so let's go ahead and see, right? So runtime is in this particular fashion, and if you talk about new profit, okay. So let's say if you have a for a single runtime, so maybe okay. So in fact, we can provide a condition on this. So let's say okay, not this particular bit. Okay, let's keep it like this. What I want to say that for, let's say, if you have a single runtime, so maybe I'll do by status. Okay, so this would make more sense. So let's say status, so false true. Okay, so let's go ahead and run this particular bit. Okay, so as you can see, status is rumored, because rumored comes let's say in descending fashion. So rumored and release are the two values which status takes. Okay, and as you can see, this is in increasing fashion, right? So for a single value of status, right? So new profit are in increasing fashion, right? So negative, then positive, and then it is in increasing fashion. So we only have only 4 observations for rumored, and then for release it again starts from negative, right? So it's in ascending fashion, right? So I hope you guys are able to understand how sort values are working for 2 variables, and there we can also specify if the descending or the ascending fashion for each of those variables. Does this make sense, guys? Sort values? Yeah, can you please let me know? Okay, perfect. Okay, that's great. Okay, so of course you can try experimenting with this, and you will be able to understand what's going on, right? So because there's so many methods, and I cannot discuss each and every possible method which is available in Pandas. Of course I can do that, but it will take me a lot of time, right? But I think it is upon your curiosity to experiment and explore all these methods. Try to see, you are having a lot of questions currently, right? Because you're learning new concepts. So whatever questions you have, try to frame them in your Python environment. Try to execute them, experiment with them, come up with new ideas, and see if how that does that work, right? So of course we're getting some output. Maybe let's say if you're getting some error, so you try to understand what that error is. If you're getting some output, try to understand why that output is being shown, right? So you need to do a lot of experimentation on your own, and of course I can discuss your doubts, but I think if you try to run these cells and try to have a look at the observations on your own, you'll have a more robust understanding of the concepts. Okay, and then in Pandas we have very good support for DateTime operations and functions as well. So let's have a look. Okay, so as you can see, we don't have any DateTime object or any data type as DateTime, right? So everything is either numeric or object data type. Okay, so and we can also get the first 5 rows for release date, which is our date column, but that is again a string, right? So it's not a DateTime object proper, right? So there is an important library, DateTime, which we can use. So I want to import this particular module DateTime from the library DateTime. So how can I do that? So what I'll write, so I'll not write import DateTime from DateTime, but I'll write from DateTime import DateTime. And then similarly, let's say if I want to import this particular module date, so I'll write from DateTime import date, right? So always keep this in mind. So let's say if you want to import a particular module or any class from a library, right? So you'll need to write from the main library import that particular module or subclass, right? So you cannot write import date from DateTime. Okay, so this is how we write in Python. Okay, the import statements. Okay, so there are two important concepts in relation to DateTime. So one is strp time, which is short for string parser time. So this will convert a string format to DateTime, right? So you see, this is a string format only, but and we want to convert this to DateTime. So we'll be using strp time. And then there is strf time, which means string formatter. So this will format a DateTime object to string format. Okay, so you'll get to know the difference between a DateTime object and a string object. Okay, so as you can see, this is of D type object. Okay, essentially a string type, right? And now let's create a new column, which I'm calling as new release date. So what I'm doing, so I'm applying this particular operation on this particular column, which is release date, and this is the operation which I'm performing, right? So this is DateTime. So remember, DateTime we imported, right? So in DateTime you have strp time. I'm not sure if I ran this, but I'll just run this again. Okay, so in DateTime you have strp time. Okay, and it has two arguments here. So one is x. So x means the release date. Okay, and this is the format of the string. Okay, because we want to convert a string data type to DateTime data type, right? So what is the format of the string we have? So as you can see, so this is the month, this is the date, and this is the year. So we can write %m, which is for month, %d, which is for date, and then %y, right? So I have listed down all these things here. So if you go through this, you'll get to understand, right? %m, month has a 0 padded decimal number, right? So it can be 0, 1, 0, 2 till 12. And then I've also mentioned %d. Okay, so this is day of the month has a 0 padded decimal number. So 0, 1, 0, 2, something like this, right? So, so this is what we have in our release date. So we can write %m, %d, %y, and of course they will be separated by slash because we have slash here. Okay, so this is the format of the string which is already present, right? And using this format, we'll parse this string format to a DateTime format. Okay, so let's go ahead and run this particular piece of code, and let's see the info. Okay, so as you can see, the new release date, which is the newly created column here, it has the D type, which is DateTime NS, right? DateTime 64 to be precise, right? DateTime 64. So this is a DateTime data type, which is a different data type which we have not seen till now, right? So when we started learning Python from the very beginning, we never encountered this particular data type, which is DateTime 64. But remember, this is the data type for a DateTime object. Okay. So now you can see this new column which has been created. So maybe I can just run this. Right. So now, as you can see, this looks much better, right? So this is proper YYYMMDD format, right? Rather than this the old way, right? So now this is the date format, and as you can see, it looks better, right? So if there were hours or minutes or seconds, we could have also provided those things here, right? We could have provided those things here, but luckily it was not there. So otherwise, we can have precision till, let's say, for hour, minute, second, and so on and so forth. Okay. All right, so let's move ahead. And now you can see the first value for this, let's say, new release date, which is our newly created column. So you can see that this is timestamp, right? And this is of type which, so maybe I can find the type of this value as well. Right, so this is pandas.libs.tslibs timestamps.timestamp. Right, so this is of this particular class timestamp, which is available here. right? So yeah, don't have to bother about it. Uh, so if you have an object or a value which is of timestamp class, so there you have different attributes for that. So you have month, you have year, you have day, you have hour, you have minute. So let's go ahead and run this particular piece of thing. Okay, and we'll just go back to the usual, so we can see what is the value here we have. Right, so this is 20th Feb 2015. So we can call this attribute which is month. So this is the value dot month, and right, so it is 2, right? So second month. Now year, so this is 2015 dot day, so this is the 20th day of the month. Then hour, so this is 0th hour, because yeah, it's we have no idea about the hour or the minute, so it's only showing 0, right? Okay, so there are other operations. So we also imported this module date, right? So it has a method today which gives you the date of today, and there is another method now which is available in the DateTime module, which you can use and call. So today is 17th Feb, and currently this is 16:19, right? But you must be wondering, right? Currently it's 9:49. So why is it? So this is Greenwich time, right? GMT. Okay, right? So how to make it Indian time in collab? So I think you can simply Google that question. Okay, so it's not a big deal. So you know how to Google. So simply Google this, right? Of course, you can explore these things, but of course we can subtract a particular aspect, right? So I'll just tell you how we can do that. Okay, so now if you want to run this datetime.now +1, so this will not work, right? This will throw an error which is type error, because this is a datetime object but one is int. Okay, so it makes no sense to add these two things together. So let's say if I wanted to subtract 1 day or add few hours, or subtract few seconds from our current times or any particular date, we can do that. Okay, so there is an important module in DateTime which is time delta. Okay, so let's call this and we'll print the today's date, and then we can subtract from today's date by calling this time delta, and in the argument we can specify days is equal to 1, so this will subtract 1 day from today. Similarly, it has other options such as hours and seconds, and we'll do the corresponding operations. Okay, so as you can see, so if we subtracted 1 day, so this is 16th Feb instead of 17th, and we added 1 hour. So remember, current time was around 16:20, so that's why it's adding 1 hour, so we're saying 17:20. And also if you want to add 60 seconds, so earlier we had 16:20, right? So it's taking the current time, right? So that's why you might think that earlier it was 16:19, but how come so many seconds were added, right? Because I executed this at later point of time, most probably let's say around 16:20, so that's why, or maybe around 16:20:59 to be precise. That's why it's giving 16:21:59 by adding 60 seconds. Okay, so you can do these operations, and of course regarding that conversion from GMT to IST, you can Google those things, and I think you can simply maybe, can we provide hours in, let's say 5? So let's say so this we can do, right? So +5, so it's around the same time, and maybe if we provide 5.5, what will happen, right? So it shows you the current time, right? So in this way we can use the time delta to account for the time zone differences, right? Got your question? Got your answer? Okay, great. So so we can do this on these operations. So essentially, see, if I just walk you through all those things, I am not expecting you guys to understand everything, but I just want every one of you to experiment with all these methods. And I'm not able to discuss all the methods because of the time constraint, but because you have a lot of time with you and you are in the learning phase, so you need to spend a lot of time experimenting with different methods, right? So go through the Pandas documentation And also in Collab, it's very handy. So you can create, just hover on a specific thing, right? So you can get a lot of information. So maybe open in tab, right? So it shows you a lot of different things, right? So you can work with these different methods, which I'm not able to discuss. In fact, firstly, experiment with those methods which I have discussed, and then you can explore other methods on your own, right? So because there's so many things to know, right? So not a sane person can do that, and that's why I'm asking you guys to become really good at very effective googling, right? So you know that, I have a date time column, and I want to add, let's say, 5 hours to that column and create a new column. So once you have this idea that this is possible using Pandas, so simply Google that and you will get that particular functionality, right? So go through the official documentation, or maybe go through any Stack Overflow answers, and you will be able to do really well. Okay, so that's great. So let's move ahead. And there are few final methods I just wanted to discuss. Of course, this is not the end of it. There are, in fact, a lot more to learn. And as we have more and more classes, so we'll be introducing more and more methods. And those things will become really clear. Okay. So the first method is unique. Okay. So it essentially counts the number of unique values in a column. Okay. So let's say I want to find out how many unique values are in a status column. Okay. So I can write firstly df. So I can write df status.unique, and this is an array, in fact, right? So this is an array, and you can convert this to a list by just passing that into a list function, right? So df status.unique, right? So unique method essentially gives you the unique values in a column, right? So maybe let's pick another. So let's see how many different original languages are. Okay, or what are the different original languages? So let's df and then original language, and as you can see, Collab also suggests you which variable you want to write, right? Because it knows it has this df in its memory, right? So it knows that this is a column, so original. So I don't even have to write, right? I guess in this case I might need to, right? So original language, but it was suggesting, right, as you might have seen, so dot unique. Okay, so it will give you all the unique values in your column original language, right? So as you can see, English, Hindi, Korean, I'm not sure which is French, Italian, and then a lot more, right? So I don't even know all the acronyms here for the languages, but you get the idea, right? So these are the unique values. And what if you wanted to count the number of unique values? So of course, on top of this, you can call the length function, but we have another very useful function, which is n unique, or the number of unique values, right? So n unique is short for number of unique elements. So let's say I wanted to find out how many original languages are there across all these 3,000 movies. So this gives me 36. Okay. And okay, so this is these are the two methods. One unique gives you the unique values of a particular column, and n unique gives you the number of unique values of that column. Let's have a look at another method, which is value counts. So this is nothing, but it will give you the number of observations corresponding to that particular group, right? So here, let's say if I provide this column df original language, and I write dot value counts, so it will essentially return you the counts of the observations for each specific unique language, original language, right? So you know that we have 36 original language in our data frame. So if we do this, so we'll get 36 rows in a way. And so English has around 2,500 movies are there, 2,575 to be precise, and then there are 78 French movies, right? Something like this, right? So this is what we can get using the value counts method, right? So essentially counts the number of observations for a specific category or a level of a variable. Okay, so I hope you guys understand this particular bit. And again, there is dot is null method. right? So essentially, if I write df revenue dot is null, so it will show me null if it will return me the boolean for those observations for which revenue is null. Okay, so in this case we are seeing only false, but what we can do, so here let's take another example. So home page. Okay, so let's take this example, home page. Okay, so home page, maybe right, so some rows are true, returning true, right? So these rows or these IMDb IDs, they have null value in the homepage column. Okay, now let's say I want to find out or get those observations in which the homepage is not null. Okay, so what I can write, so I can write something like df homepage, okay, and dot is null. So of course this will give you the true boolean, but we want to have those observations which are not null, right? So that's why we'll add a tilde before it, right? So this will eventually flip the boolean, so it will make true to false and false to true. Okay, so let's see these observations. So we'll not be finding any such observations in this data set, in this particular subset where the home page is null, right? So as you can see, so kahani, possession, dreamworks, right? So we are not having any null values, right? And as you can see, we have around 946 rows and 24 columns. Okay, and similar final method which I just wanted to discuss with you guys, which is fill NA. So let's say if I wanted to fill all the null values for home page, right? And what value do you want to fill with? So let's say minus 999, or maybe let's say maybe a string not available, okay, or not present, something like this. And then I'm writing in place is equal to true, so this will invoke the change in place. Okay, so our data frame will get changed. So let's have a look, right? So here, as you can see, home page for which we had null value, so it has been filled with this particular string which is not present. Of course, you can fill this with any numeric value or anything which you deem relevant. Okay, so this is what overall I wanted to discuss with you guys in Pandas operations. And in fact, I cannot emphasize this enough that we have a lot more methods and functionalities available in Pandas, right? This is a really huge library, and as we have class tomorrow, and then we have the guided projects, and then you will be of course doing cell project. We'll have the data visualization class on Friday. So there, which time we'll be discussing newer methods so that you get familiar with a lot of different things. At least you'll be able to get familiar with what things can we do. Okay, so for now you might have been seeing the null values, but you did not know whether can we fill them or replace them or not, right? So but now you saw that, yeah, we do have that fill NM method, right? So think of any such possibility. Can I do this in Pandas? Can I do that, etc.? And try to Google those things and see if that's possible at all. Okay, so it's totally dependent upon your own curiosity, what you want to do, right? So the most you need to identify, or the best you need to identify, is what you want to do. Once you have identified that, you can simply Google those things and do your work, right? So it's not that difficult, right? I do not personally memorize all these functionalities or methods as available in Pandas, but I know, I keep in mind, yeah, I want to do this particular task, and from my experience, I have seen that I can definitely do this particular task. Now let's see how we can do that. So maybe I'll Google it over Stack Overflow, or go through the official documentation, copy paste the snippet in my Python code, and change the few variable names, etc., and it will work like magic. Okay, so this is what I wanted to discuss with you guys.